Now, palladium has 10 electrons in it, and if each ligand donates 2, if they're sharing, they end up with 18 electrons, which is like a noble gas structure. So that's what a stable palladium complex will look like if it's palladium 0. And palladium 0 is actually a stable oxidation state, and not just for the metal, but for complexes. So you can have things like this. Now these are not, these triphenylphosphines, remember phosphorus is below nitrogen, so it has a lone pair on it. And these 4 phosphines are not, this isn't a normal covalent bond, it's really a donation of a pair of electrons from the phosphorus onto the palladium, and then there's some back donation via the d orbitals into the vacant orbitals on the phosphorus. And overall that's a fairly stable structure, but because these are quite bulky ligands, they can fall off, and then you get a 16 electron complex, which is a bit more reactive. And if the ligands are bulky enough and it's a good day, you may get 2 ligands falling off. And the one with 2 ligands fallen off, which has just 14 electrons, is quite reactive, and that's the main catalyst for these palladium catalyzed couplings. So you have something like this. And the most popular catalyst for these palladium coupling reactions is this compound, which is often known as tetrakis. And it's not because you have 4 phosphines kissing the palladium, it's tetrakis triphenylphosphine palladium 0. So we take this is the active catalyst, and we put that in the cycle with our vinyl halide, aryl halide, whatever, and also the organometallic or the organoborane, organosilicon compound, whatever it is. For example, if you look on page 329, you'll see the mechanism written out as a cycle, which is often the way these organometallic or inorganic mechanisms are written. So we've got something like L2PD, our 14 electron thing from here, and this is still palladium 0, and that can add a vinyl halide or something like that and give us now this is 18 electrons, so that's a lot happier. This can do an exchange. We're familiar with organometallics replacing a halogen with an R group. We've just seen it with the organocuprate chemistry. So this can come in and do an exchange. It happens quite well with these palladium complexes and gives us N the two R groups on the palladium. Has to then do a rearrangement, put the now these ligands, if they're bulky, can be going on, coming off, and that's probably how this happens here. And now these are lined up to give us the coupling product like that. And the net reaction